Afternoon or good evening, depending upon when you're watching this video. This is your Ed Puzzle for 11.1, introducing the last chapter of your geometry course. Now, this whole chapter is all about volume and surface area, but before we get into that, we got to know some of the basic facts. Here we go. The first fact we really need to understand is what is a polyhedron, because this whole chapter is going to be about three-dimensional figures. Three-dimensional figures are how we're going to find volume and surface area. So just another word to know about them is they're called polyhedrons. Now, parts of polyhedrons for us to recognize, we got the faces, which are all the different surfaces that comprise to make up your polyhedron. We also have edges. Edges are these segments that are the edges of each of the surfaces, okay? Other pieces to know are your vertices. Your vertices are your corner points, like here, and here, and here, and so forth and so on. Okay, so let's get into our first example. We need to identify how many vertices, edges, and faces are in the polyhedron to my right here that I'm circling, okay? And we're going to list them up. First thing to identify are my vertices. Looking at this figure, how many vertices are there? There are a total of 5 vertices. Now, if I look at all of them in each of the corners, I can identify who the 5 vertices are. We have D, E, F, G, and H. 5 vertices, 5 corner points that make up this polyhedron. 8 edges. How did I come up with 8 edges? 8 edges. If I highlight one of them, I'm noticing I have an edge comprised of DE. If I continue around, I'm also going to have to recognize that I have edges that are appearing to be diagonal, such as HE. Now, segments are the edges. So notice all of the 8 edges that I comprise myself with. DE, EF, FG, GD, DH, EH, FH, and GH. Next up, I want to look at the faces. Now, the faces are the surfaces that comprise to make up my polyhedron. Now, I do have a pyramid appearing here, and comprised of this pyramid, we're going to have, I see 4 faces on each of the sides, and we also have a base face. Yep, that just rhymed. So the faces that we have on the sides, there are triangles. We have 4 triangle faces. And on the base, we have a quadrilateral. So when I name my faces, the first face I see is DEH, which is a triangle. I also have triangle EFH, triangle FGH, and triangle HGD, or GDH. And on the base, we have quadrilateral DEFG. A reminder that I want to remind you of is the fact that when you're naming quadrilaterals, we go around the perimeter. So this is D, E, F, G, all around the perimeter. You can't cut across the diagonal. All right, here is your got it. You need to identify how many vertices, edges, and faces there are in this polyhedron to the right, and then list them. And then I also want you to decide, is TV an edge? Explain why or why not. Solutions. Please note the reason why TV is not an edge. Notice that TV is a segment that is contained within one of those faces. It's not one of the intersection of 2 faces. Therefore, it's not an edge. So a new concept that I'm not sure if you learned about in middle school is called Euler's formula. Now, Euler's formula says that the sum of the number of faces, vertices of a polyhedron is 2 more than the number of its edges. So this is my big idea that I need to use. Faces plus vertices equals edges plus 2, okay? So let's apply this new formula that we got. We first need to identify with this polyhedron how many vertices, edges, and face the polyhedron at the right has. And then we're going to use these to verify Euler's formula. So looking at this polyhedron, I'm noticing that I have a total of 8 faces. So I'm going to say to myself, the number for F is 8. Because around the rim of my polyhedron, I'm noticing that I have 6 rectangles, and then I have a base here and a base here. Okay? So we have 8 faces. The next thing I want to notice is how many vertices we have. Okay? In total, we have 12 vertices. Okay? I can count the number of vertices by recognizing how many points we have all around. Notice that there are 6 on the top, and then there are also going to be 6 on the bottom. Okay. Lastly, I want us to determine how many edges we have. And in total, I'm counting 18 edges. Now I can count that by going around 1, 2, 3, 4, 5, 6. I'm also going to have 6 on the base, but the thing that I cannot remember, or can't remember to not forget, is I need to count these edges all around. So all around we also have a total of 6. So 6, 6, and 6 gets me 18. Now Euler's formula is as follows. Face plus vertices equals edges plus 2. And I'm verifying it, so I'm going to put a question mark in the middle because I need to see if I'm correct. So we have 8 for faces. We're going to have 12 for our vertices. And for edges, we have 18. I'm going to fill in my rest here. We're questioning the equality of this statement, whether or not it's true. But last I checked, 8 plus 12 is 20. And last I checked, 18 plus 2 is 20. Does 20 equal 20? Well, yes it does. We have verified Euler's formula. You have 2 to do. However, I want you to notice that you are going backwards. You are going to use Euler's formula to solve for the missing piece. Here are your solutions worked out. Check over your work. All right, next up, we are going to go into two-dimensional figures. Now, in 2 dimensions, Euler's formula is going to reduce to number of faces plus the number of vertices is equal to the number of edges plus 1. Okay? And what I mean by 2 dimensions is it's helpful for us to unfold the polyhedron to produce a net. So if I take my polyhedron to the right, and actually maybe I'll just show us a video to see what this looks like when we unfold it. Open this up. Here's my polyhedron unfolding the bases and the edges, producing this net. Hopefully that was a little helpful to you. So here is the net produced to help me figure out how many faces, how many vertices, and how many edges are produced. Okay? Well, the number of faces is now actually going to refer to the number of regions. Okay? And I'm counting 1, 2, 3, 4, 5, 6, 7, and 8. So we're going to have 8 for our value for F. Okay? We're going to count the number of vertices. Vertices is still going to be the same idea. Now when I count the number of vertices, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We have a grand total for vertices of number 22. All right, the next piece that I need to count are my segments. How many segments do we have here? Segments are going to be my edges, okay? If I start to count, 1, 2, 3. I'm going to have 3 up here. I'm going to also have 2 over here and 2 over here. So far I'm up to 10 edges, okay? Got another 2 here, so we're up to 12, okay? Also edges here, 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 and here. Oh my gosh, I'm still not done. So I also got to go all around the top and the bottoms here. So notice, if I count out all these edges produced, I'm going to have a total of 29 edges, okay? Euler's formula for 1D, aka using with my nets. We're going to use this guy up here to verify whether or not it's true. So my value for F, we have 8. My value for V, the number of vertices, we have a total of 22. I am questioning its equality here. And I'm going to set this equal to my 29 plus 1. Okay? By the way, this is called an algebraic proof for those of you who did not know. First up, 8 plus 22. Last I checked, I got 30. And last I checked, 29 plus 1 was also equal to 30. Does 30 equal 30? Well, yes, we have just verified Euler's formula for 2-dimensional figures. Here's your got it. Using the solid at the right, I want you to also verify Euler's formula. Once again, please note, you're first doing this for the polyhedron as shown. Next, in part B, you are going to draw a net for the solid and then use that to verify Euler's formula for 1D figures. Let's first check up your answer for A. Did you repeat the exact information from this previous example? All right, it might be helpful to verify your net. Your net could look like this. If you did not produce a net that is similar to this to produce the same numbers for F and V and E, please use this net because that'll help you verify in part C your answer. Let's keep going. The next idea that we need to have is a cross section. A cross section is the intersection of a solid and a plane. So you really need to get your visualization cap on so you can think about what is getting cut, what shape is produced. Okay? So notice that I have a polyhedron, and when I cut this with a plane, this rectangular looking plane, I'm focusing in on the shape that I'm cutting. Okay? So we need to identify the cross section formed by the plane and the solid at the right. So I know that I've got a cylinder here. Okay? Mentally, I'm trying to rotate this solid so that the plane is parallel to my face. Okay? So let me do that for us. So now I'm kind of trying to picture what is the shape being formed. And what I am seeing is I am seeing a rectangle. A rectangle being formed when I slice this cylinder with a plane. So the cross-section shape formed is a rectangle. Let's see if you can do this with this new solid at the right. Identifying the cross-section formed by a horizontal plane. Remember, horizontal, we go from the left to the right. And then a vertical plane, that means we go up and down. Shapes that you should see with horizontal, you're going to get a circle. Now, depending upon your height, it's going to be a different size circle. Now, if you do vertically, dividing the solid into perfect halves, specifically, I want to know, because you cut it into perfect halves, it's going to be an isosceles trapezoid. All right, last example. We need the ability to draw a cross-section, okay? Now, to draw a cross-section, sometimes it's helpful to use the idea of the previous postulate in Chapter 1.
Brian Jones, please come to the main office. Brian Jones to the main office, please.
Well, apparently they make announcements in the middle of the morning. Anyways, back from Chapter 1, when thinking about that the intersection of two planes is just a line, okay? All right, so I've got this appearingly cube. It is a cube according to the question. And we need to draw a cross-section formed by a vertical plane intersecting the front and the right faces, okay, of my cube. So the front face is this guy here. My right face is this guy here. So a plane intersecting those two faces, and we need to identify the shape, okay? So the first step, I want to draw out the plane that intersects those, okay? Visualizing what is appearing here. Now, I want to focus in on something. I want to focus in on these two lines right here. Because I am being cut by a vertical plane, these are parallel segments, okay? Now, when I have parallel segments and I join together their tops right here, oopsies, move my board there. Think about what shape is created. What shape does this appear as? It appears as a rectangle, okay? Last got it? You have to draw the cross-section formed by a horizontal plane intersecting the left and the right faces of the cube, and I want you to identify specifically what is the shape formed. Well, your shape formed would be a square in this scenario. Once again, this has been your notes, the very first section for notes for 11.1. I hope you have a great day.